Hello, I'm Ian Johnson. I'm Technical Support Director at Lumencor from Beaverton, Oregon. And I'm here today to talk to you about our solid-state illumination technology for life sciences. That technology is deployed in devices that we call light engines. So we're going to start first off with the Spec light engine. So this is a solid-state light source. It contains an array of LEDs and a device called a luminescent light pipe. And it, as you can see in this demonstration here, those six light sources, each of those six light sources outputs a different color. And the colors together compose the visible spectrum spanning from the violet region, green, blue, through to the red shown there. These light sources can be switched on and off very rapidly for microscopy applications. The control comes from a computer back here, and the user would be working at usually a desktop workstation that would be running software that feeds into the light engine through a serial connection. Alternatively, there is the option to turn these light sources on and off by TTL triggering, in which case we would use a cable connected to the camera by this device over here. This is a TTL breakout cable that would be used to connect the light engine to a camera for the purpose of selecting these individual sources and turning them on and off. The light output from the light engine comes out of here into this device, which is called a liquid light guide. The liquid light guide would take the light and eventually put it into the epi-illumination port of a microscope. To do that, we use this device here called a collimator, and the light guide would simply be inserted into the end of the collimator. The light output comes out there, and that would be directed into the microscope. So now we're going to move on to the solar light engine here. The solar is a simpler light source than the Spectra X that we just looked at. In the solar, there are 5 solid-state light sources inside this box, and they're all run together in so-called gang mode, and they produce a white light output. If I put my business card down there, you can see white light coming out from the light engine into the end of the light path here. The user would split up the white light output using a device like I put a dichroic mirror into the output beam there, and that splits the white light into cyan, which is going straight ahead and creating fluorescence on this acrylic block, and then green light going out this way, which is exciting orange fluorescence on this acrylic block. Now, in a real-world application in microscopy, of course, these samples would be tiny, invisible to the human eye, but this makes a nice macroscopic demonstration of the light output that's being used to do that experiment. With the solar, again, a computer can be used. We also produce a purely manual control version of it. Or also, for convenience, we use this controller pod. So this has essentially the function of a dimmer switch. So we can increase the light intensity by winding the dial up there. As we increase the light intensity, we generate more fluorescence in the sample back here. And again, we can dial it down. Again, using the dial here, we can turn it on, turn it off, on, off, on, off. One of the features of this is that capacity to switch on and off very rapidly. In fact, a manual control like that is very, very slow compared to the time scales of the experiments that these light engines are used for. In a real experiment, you'd be using a computer that can switch the light source on and off much more rapidly than a human could ever see or do. Thank you so much for watching this brief description of Lumencor's solid-state illumination technology. There's much more information about all of the light engines that I've described to you, and many more that we manufacture, on our website, www.lumencor.com. If you have a need for modern solid-state illumination technology in your research or in products that you manufacture, then please contact us at Lumencor, again by visiting our website at www.lumencor.com. Thank you.